Hi everyone, welcome to my channel. Today in this video, we are going to see the implementation of the decision tree algorithm. If you have not seen my previous video where I have explained the concept as well as the math behind the decision tree algorithm using ID3 as an example, please check the previous video where I have explained in detail about the decision tree. So in short, like quickly, to give you a recap about the decision tree algorithm. So decision tree algorithm is an supervised learning algorithm and it is non-parametric, which means that there is no strong assumptions that are being made, whereas most of the learning comes directly from the training data. So the more the data you have, it's better for the decision tree algorithm or any other non-parametric algorithm. So decision trees can be used for both classification as well as regression problems. Some of the key terminologies in decision tree are the root node, terminal node, the decision node, the split, pruning, and random forest and pruning are the techniques that are commonly used in order to avoid the overfitting. So these are all the various concepts that are covered in detail in my previous video, and in my previous video I have also covered the implementation or the mathematics behind building the decision tree using the ID3. So how the entropy as well as information gain are used, what are all the formulas, how they are used in order to build the decision tree. So how do we identify various attributes, which attribute should become the root, which should be the next decision node. So all these are being generated based on the entropy as well as information gain in case of ID3. So in case of different algorithm, the techniques can be different, but more or less the methodology would be similar in case of any decision tree algorithm. So if you haven't seen it, please go and check those videos and before getting into the implementation of the decision tree algorithm. So now let's assume that you know about the concepts behind decision tree, the mathematics behind it, and let's get into the implementation and then see how to use or how to implement the decision tree for the sample data that we saw previously. So these are all the various packages or libraries that we will be using in order to implement the decision tree algorithm. So as you see here, the decision tree classifier, that is the important library which is used in order to build the decision tree. So we use train and test split. So this is common in any algorithm that we are going to use. Any supervised learning, we will be using this particular library in order to separate, in order to divide the data into training as well as test data set. And we use confusion matrix in order to measure the accuracy of the model, how good the model is performing. So confusion matrix is commonly used in case of classification problems. So it can be like 2 classifications or 3 classifications. There can be multiple classes. So in any of those classification problem, confusion matrix can be a good method in order to measure the accuracy of the model or how well the model is performing. And we have export graph viz as well as we use matplot library in order to make some charts from like here in this case we are going to use these libraries in order to print the decision tree and then see how the tree looks like. And we are going to use sklearn and of course Pandas as well as NumPy, because the data set could be like the data set here in this case is a data frame, and NumPy because if there is any numerical attribute. So in today's example there aren't any data that is numeric, but what we will be doing is we will be converting that, we will be using integer encoding and we will be converting those categories into numerical attributes because it becomes easy so that it can be used by the algorithm. So now these are all the various packages that are required for today. So what I'm going to do is I'm going to execute and import all these packages. So let me just clear the output and let me go here. So I'm going to import all the packages that is required for today's exercise. So the next one is I'm going to read the data set. So this is the data that we are going to use. So it is the sample data that we used in the previous session in order to explain the mathematical concept behind the decision tree. So let me read this data and then show you. So as you see, so this is the data set that is exactly same as the one that we covered previously while covering the concepts. So we are going to see how to build a decision tree if the data is like this. So we have 4 attributes here: outlook, temperature, humidity, as well as windy. We are going to use these 4 attributes to decide whether to play or not. So these are all the cases where we know like what kind of decisions were made when we had these types of values. So this is the input data set. So now what I'm going to do is the next one. So since these data is in the string format, so which is not suitable while implementing using Python, using the decision tree classifier. So what I'm going to do is I'm going to use integer encoding. So for all these cases, for example, here in case of outlook, so if it is going to be sunny, I'm going to encode into 0. If it is overcast, 1, and if it is rain, 2. So I'm going to use all these integer encoding, and then I'm going to use the map functionality in order to replace the values, all the string values, into integer equivalent. So let me execute this and then show you how the data now look like. So this is how the data looks like now. So we have converted all the strings into integers so that it can be used or consumed by the algorithm as such. So now what I'm going to do is I'm going to divide the data into the independent variables as well as dependent variable. So here x is the independent variable, the input that we pass on to the algorithm, and y is the target column or the dependent variable. So I'm going to divide it into 2. So let me just execute this. So x becomes the independent variable and y becomes the target variable. And then what I'm going to do is I'm going to use train test split in order to split them into training as well as test data set. So this will be very helpful when the data is huge. So here in this case the data is very small. We have only 14 instances, but still I'm going to use this, and then I'm going to separate that into test as well as train because we want to follow the methodology that will be used when we have the actual data. So let me execute that. So now the data is divided into training as well as testing. So h underscore train has the training data set, and y train as y test and h test as the test data set. So the ratio here is about 70% for training and 30% for test. Then the actual model building comes here. So here I'm going to use decision tree classifier. So all I'm going to do is I'm just going to pass on the depth of the tree. So we saw in the previous video the other 3 hyperparameters that are commonly used, which is criterion, where we pass what type of method should be used in order to build the decision tree. So if we want to use ID3, we pass entropy as an option, or we can use gain ratio if we want to use C4.5. So depending upon the algorithm, we can pass on the criterion. And then there are the parameters that can be used here, which is the maximum number of terminal or leaf nodes, the number of samples that is required in order to split a particular node. So these are all the various parameters that can be used. So here what I'm doing is I'm just using the max depth and then setting it into 3. And then I'm using, so this is where the model has been initialized to. So I'm using .fit in order to train the model based on the training data set. So I'm passing both x train as well as the target attribute, which is in y train, and this will be used in order to train the model. And finally the predictions are stored in the predictions attribute here. So let me execute this script here, and now the predictions has been made. So now what I'm going to do is I'm just going to show you the actual prediction. So this is the predictions that we have made, and y test has the actual values. So this is the actual values. So we can see the prediction matches in 2 cases. So here in this case the data set is very small. It has only 14 instances, and we are dividing that further into training as well as test data set. About 30% of it has been removed for test data set, and hence the accuracy is quite low. But as the model or as the data increases, as you have a good number of data set, so then decision tree will work amazingly well. And so now we are going to see how the tree looks like. So first one, so here this one gives you a representation, a text representation. So this is how the tree would look like. So this is the root node, the feature 1. So in order to make it more clear, so what I'm going to do is I'm just going to use the plot functionality here, and then so that it becomes visually more appealing. So if you see here temperature, so here the attribute temperature is a second attribute. So here in this case, so what happens is the feature starts with 0. So it starts with index of 0. So feature 1 is the second attribute, which is nothing but temperature, the one that we see here. So what happens is if it is less than 1.5, so then it goes here. Otherwise, if it is greater than 1.5, it goes here, and then the tree ends right there. So the one that we see in this color it means that the tree has officially ended. So in the other cases, the tree is they are still blue in color, but what happens is, since we have given the depth as 3, the algorithm has stopped here. So maybe if we are going to increase the depth, then we would have a much more or much better tree. So that's about the tree. So here in this case, the tree has been built like not using ID3 algorithm. So you see that the tree is slightly different as compared to the one that we saw in the whiteboard in the last session. And then finally, measuring the accuracy, we can use confusion matrix. So we can see that we have made 2 right predictions. This diagonal provides us the value of the right predictions that we are making. So we have made 2 right predictions, and then in 3 scenarios we are going wrong. And that's it about the implementation of decision tree algorithm. So decision tree is quite simple. It's very intuitive because we would be able to interpret the algorithm, because the decision tree is built based on various decisions or various decision logics. So it is very easy to interpret the output to a business or to the various stakeholders that are involved. And the decision tree can be also used in order to identify the various attributes that are key in order to make the prediction. So you can still use some other algorithm, but you can use decision tree in order to identify the key attributes or key features that plays a major role in the prediction. And then you can use those attributes, you can select those attributes and use some other algorithm as well. And coming to the next one, so here the next steps are the link, the title link that I have provided here gives you a very good tutorial about the implementation of decision tree. So it has a sample data and it has the various implementation using different algorithms, and then it also provides you like the various data preparation that would be involved while building a decision tree. So it kind of provides you an end-to-end view like in building a decision tree. So I would recommend you going through this particular link to better understand about the decision tree algorithm. And finally, when you are comfortable with implementing a decision tree algorithm, I would suggest you pick up the Titanic dataset and use decision tree in order to implement, and then see how your predictions are, how good your predictions are. So that's it about decision tree algorithm. So decision tree is commonly used in many classifications. So this concept is being commonly used in many classification problem. For example, random forest, batting, or boosting methodology. So much of the learnings or the concepts are being taken from decision tree. So in case of random forest, what happens is we try to build multiple trees. So one option is we take various samples of data, we build multiple decision trees, and we take the average of all the decision tree. Also, we take various subsets of the features and then build number of decision tree and then take the average of them in order to make the final prediction. And hence what happens is overfitting is avoided. And in a number of scenarios, I have seen that random forest algorithm works best in order to make what's best in making an accurate prediction. And in a number of title competitions as well, I have personally used a decision like a random forest, and it has given me much better results. And that's it about the decision tree algorithm and its implementation. And if you like what I am doing here, if you are learning something new, please give a thumbs up and subscribe to my channel. If you know someone else who might be interested in learning data science, please share this link with them. And if you think there are any material that can be very helpful in order to learn more about a decision tree or random forest or any tree based algorithm, please provide those links and materials in the comment. Also, if you find it useful, please share it in the comment. It helps in making sure that my video reaches a large number of people. That's it for now, and see you in the next session. Bye until then. Bye.